Welcome to our physics class. We are looking at equilibrium of forces. Equilibrium of forces. Okay, that's the topic we are looking at. And now this question, take note in equilibrium of forces, we have to take measurements. Okay, before we go to this question, please, if you have a meter rule like this, okay, usually measuring 100 centimeters. Okay, usually we want to keep this meter rule at equilibrium. Okay, and the pivot support is mostly placed at the center of the meter rule. So from here to here is 50 centimeters, and from here to here is what? 50 centimeters. Okay, before we go to this question, I want to explain this. Okay, from here to here is 50 centimeters, and from here to here is 50 centimeters. Okay, so now we can say that this can be left on top this pivot and is at equilibrium. Okay, it can, okay, before we put forces here or forces here, this meter rule is at equilibrium on this pivot support. Okay, meanwhile, if we should have a force from any direction, maybe a force here and maybe a force here, okay, we can take the moment of, forces. Okay, the moment should be the clockwise, okay, equal to the what? Anti-clockwise. All right. So, and also take note that the weight of this meter rule is usually acting at the center of the meter rule. Okay. Now let's go to this question. I just wanted to open up our minds, okay, to understand equilibrium of forces. The moment of couple, okay, is the clockwise moment equal to the anti-clockwise moment, and the moment is also equal to force times distance, the distance of the force to the center or to the pivot support. This question now says a uniform meter rule AB. Okay, let us draw the meter rule AB. Okay, this is AB. Okay, is balanced on a knife edge, which is 55 cm. So we are assuming that once we know that this is a uniform meter rule, it means it measures 100 centimeters. Now it is balanced on a knife edge, which is 55 cm from B. So from B now, we have 55 cm, and we now have the pivot here. Okay, so we have 55 cm and we have the pivot there. Now, if a mass of 10 grams is hung at P, which is 10 cm from A, so we can measure A, move, okay, this is from here to here, that is 10 cm, okay, that is where P is lying. P is 10 cm, so it means that P is also from here, or this is, so we can say from here to here now will be 45. Take note, remove 45 from 55 from 100, 45 will remain. So 45 minus 10, that will give us what? 35 cm on this side. Okay, so if a mass of 10 grams is hung at P, so this is 10 grams. Okay, now calculate the mass of the meter rule. Remember, I said the mass of the meter rule is usually at the center of the meter rule. The center of the meter rule should be somewhere here, should be at 50. Okay, should be at 50 somewhere here. So this is the mass of the meter rule. So from here to here now, we are saying is what? 5 centimeters. We are looking for this M. So have clockwise moment equal anti-clockwise. Okay, so it means M, which is the mass, times what? This is distance to the pivot is 5 times 5 centimeters is equal to 10 grams times what? Distance to this place is what? Times 35 centimeters. Okay, it follows that M is equal to 10 times 35 divided by what? 5. If 5 cancels 35, we have 7. So it means M is equal to 10 times 7 which is what? 70 gram. So the mass of the meter rule, which lies at the center of the meter rule, is what? 70 grams.